Let's go back to number 10, linear. Number 12, 5 halves x minus 1 half. Number 22, P.S. What do you think, me as a math teacher, or even just me as a human being, what do you think I would prefer for you guys to do with numbers? Make them as decimals or make them fractions? Why do you think fractions? I agree. That's exactly what I would like. It's a bit cleaner, number one. It's easier than doing math by hand. Where do decimals come from? Calculators. Now, some of you think in decimals, maybe because of money. Maybe that's why. I mean, mixed numbers are probably most logical in the sense of like, hey, measure 5 halves. Well, you're going to get out a half cup and do 5 of them? No, you're going to think it's 2.5. Okay, 2 full cups and then a half. That's if you're doing baking. Anyway, so, I mean, 5 halves is good for playing with numbers, for plugging in numbers, for solving with numbers. 2.5 is messy because what if I was to ask you in the next section or the next problem or even right now in class, hey, what's f of 2? What do you want there, 2.5, 2.5, or 5 halves? Yeah, 5 halves is the easiest one to use. That's why I like improper fractions. It's the easiest one when doing by hand math. Sorry, there's the graph of your line. Guys, just quick reminder, how do we always graph lines when we have y equals mx plus b? Someone asked me this yesterday. Not specifically asked me, but they just needed to remember. How do we graph a line? Start with the y-intercept. So I have a y-intercept at negative 1/2, and then how does the slope work? 5 is how much you rise. So rise 5 and then run 2, right? So you can go up from negative 1/2, 1, 2, 3, 4, 5, over 1 and 2. Got it. How do you go backwards to get points that are before or earlier than your original intercept? Down 5. You can go down 5 and left 2. Why? Because a negative over a negative is still a, got it. Just make sure that your slope is uphill if you have a positive slope, downhill if it's a negative slope. This one, did you guys shift it left 2, up 3? Just kidding. Weren't you just using your graphing calculator? Yeah. You should have been good as long as you ended the square root. Just a few of you might have had the square root go on a little too long. If you ended the square root, you should be good. Number next one. Ugh. For number 28, the trickiest one was probably D. The trickiest one was probably D. Did anybody put negative 18 for D? That's it? Oh, okay, okay. Well, okay. Let's go to our notes really quickly, because we didn't get to talk about this guy very often, or very much, I should say. Step function, this guy, double brackets. He's the guy that this problem is talking about, okay? Step function. He could have x in there, he could have x plus, he could have 5x minus 1. Step function, he's the guy with double brackets. And what does he do? The easiest way of remembering what he does is he rounds down to the greatest integer. And last year you guys might have called it the greatest integer function. Did you guys see the steppy one last year? Oh, okay. That's all right. Rounds down to the greatest integer in the value. Rounds down to the greatest integer in the value. Ooh. Oh, my black marker's missing. It was my water bottle making noise. Okay, I'm going to zoom in on the graph because I want you guys to see what's going on. All right? The graph might help some of you visual people, and if not, then I'll show you an example on, or using the problem that we just saw. Okay? The x value here would be 0, right? And then what's the y value? X value here could be 0.5. What's the y value still? 0. 0.9. How about 0.1? How about 0.7? All of these 0, 0, 0, 0. Do you see the numbers rounding down to the greatest integer, which is the greatest counting number in the value? What's the greatest whole number in all of these? 0. But as soon as I go here, what am I allowed to say? What's the greatest integer in this guy? How about 1.1? How about 1.372? How about 1.9? Still 1. Not 2 yet. Now here's where it gets weird. What about negative 3.7? The common mistake, aka the common wrong answer, would be negative 3. What? But we're rounding down. 3.7 is 3. You're exactly right. Negative 3.7 is negative 3. You're exactly wrong. Why? Number line. Here's negative 3. Here's negative 4. Here's negative 3.7. If you're rounding down, you're rounding to negative 4. Why? Has negative 3.7 gotten to negative 3 yet? No. The same way that 0.9 hasn't gotten to 1 yet. The same way that 3.7 hasn't gotten to 4 yet. Negative numbers, the magnitudes, aka the greatness, the absolute value of the numbers, grow as you go to the left. Positives grow as you go to the right. So therefore, it's going to look weird, but technically, the clue still works. You're not rounding down in the sense of decimals. You're rounding down in the sense of the number line. And that's where it might trip up a few of you guys. And those of you that did on the one that we just saw in homework, did it incorrectly on letter D, this is what you didn't realize. The greatest integer in negative 3.7 is actually negative 4. It hasn't gotten up to negative 3 yet. So let's go back to homework and see if that makes sense. So checking out the ones that you were supposed to plug in. Well, you were supposed to plug in negative 2, but you ended up in the brackets with negative 2 plus 3, 1. Oh, greatest integer is 1. Plugging in 1/2, you get 3.5 or 3. Plugging in 4.2, 7.2, which is 7. Do you see now why plugging in negative 21.6, getting negative 18.6, rounds down to negative 19? Okay, it's weird, but you just kind of have to get your brain used to it, and it should be okay. Number 40. Hey, doesn't he look a lot like the Pre-Cal Graphing Calculator Handbook? Except you don't have them. Don't worry, they're right here. Okay. Some of you were like, it would have been nice to have last night. Valid. So let's get it back to you. That way you can refer back to this. Wait, what part of the handbook reminds us how we... Isn't it the very, 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 very end? So as soon as you get your Graphing Calculator Handbook, why don't you guys go peek at it and make sure that you remember how to do this. Oh, row 1. Kim, go ahead and pass back. Take yours, pass back. These aren't by groups, they're by rows. Find yours, pass back. 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 Here's calculator worksheet number 2. Find yours, pass back. Same. Same. Oh, sorry, Robbie. Same. 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 And then same, same, same. I've officially passed back all the worksheets that I had turned in. I think a couple of you might have some missings. Check out your RenWeb, make sure that I got them. If you didn't get back 3 things, you should have gotten back the handbook, worksheet 1, worksheet 2. Oh, yeah, yours are going to be in there. Thanks, Gavin. I have no idea what row you were, though. Where'd you sit before? Okay, so that'd be 4. Yeah, Sam. Oh, thank you. I was hoping they would show up somewhere. Kim, here's yours. Oh, you know what? I don't think you got a grade for it because the TA didn't know. Okay, I'll get you a grade for that. And then he dropped. You guys checking out the piecewise functions, trying to find it? We're trying to review how you could have done it on your calculator. Thanks, Gavin. Okay, but technically, was this a problem to be done by hand or by calculator? Okay, so is it good to review and remember how you could use your calculator to do this? Yes. Can you guys remind me really fast? I'm not going to type it all in, but how do you take something like this and put it in your calculator? How many y equals are you going to have to use? 3, good, because there are 3 different pieces. I need to use y1, y2, and y3. I'm going to put each of those pieces in separately. I'm not going to do all 3 right this second. Let's just do the first one. So if I go to y1, sorry, let me get rid of all the calculus stuff that's showing up. All right, how do I do the inequality again? Don't do second math yet. Okay, so I can put, I think I can do parentheses, right? You guys remember the whole second delete? You can insert something. Do you guys remember that cool shortcut? And then you can do your second over to get to the end of a string. What operation do I need to do the comma? Is it a comma? Good, it's a division. Then what? How do I do x? Where do I find this guy? Yeah, guys, back of your handbook, it literally has the buttons, right? It has the buttons. Second math, the test menu, and then less than or equal to, right? -1. Okay, will that get me the piece that I need right here on the left, this line? Yes. What's different? Just remind me real fast. What's different if I was trying to do this inequality instead? Yeah, you have to do this one with -1 less than x and, which is second math over, right? And x less than or equal to 1. Good. You have to split this up in the calculator. It doesn't understand otherwise. But pause. How could you? Ooh, someone who got it right. How did you graph it by hand? Yeah, Gavin. How did you know what points to plug in for like this guy? And why'd you choose -2? Good. Gavin looked and said, hey, this guy's less than or equal to -1, so I can plug in -2. Plugging in, you should have gotten hopefully -3, right? So if he did -2, -3, couldn't he have also just plugged in -1, the or equal to, and then just made his line, right? Okay. So Kyle, I saw you raise your hand too. How'd you do the parabola?
Well, I know, I kind of know my transformations, so I know that the y-intercept is -1.
Okay, so you were thinking transformations and shifting?
But then you also have to solve for the 0. You can also plug in.
I'm showing which piece I plugged into. So first of all, he was like, hey, I think, or maybe even by plugging in a 0 really quickly, right? That could have worked also. But either way, that just backs up his hypothesis of the -1, so we knew this one right here. But then you kind of need to know either side.
But it's easy because you can look at the inequality.
You can look at the inequality as far as which one's going to be open and which one's going to be closed, but you still need to know the points, right?
Yeah.
So maybe it would have been good to go ahead and plug in -1 as though this one was legal. And if you had plugged in -1, even though it's not allowed to be a point, so I'm not going to put it in the table because it's not an actual point, I can still figure out 2 minus 1 is 1. I can figure out the location of where it would have been, where it goes towards. And then plugging in 1, that one's an official point because it's allowed to be or equal to also 1. And most of us know parabolas are like swoopy swoops, right? Yep. So then, even though it technically doesn't work, it's going to be a hole. We still plug in to know where the location is, and you get 0, which is where the hole is from. And then using Gavin's advice, couldn't we just plug in, I don't know, what do you guys want to plug in? 2, 3, 10? Just do 2, because it's greater than 1. And so 1 minus 2 squared equals -3. Got it. Now wait a minute, is that a straight line? Do you see how there's just a little curvature? Because if it were to keep going, it would have had its full concave down somewhere else. But tables work, guys. Tables work. You have an idea of, it's a line going up, it's a parabola facing up, and it's a parabola facing down. So you're like, yay, yay, and, well, kind of a frown. There he is. Does that kind of make sense? Austin. Yeah. Uh-oh. Let me come back and peek and see how you plugged it in, because I bet it's just one little thing that's messing you up. Let me get everyone else grading real quick, number 48. Because number 48, you guys have some things to talk about with x squared, x cubed. Hopefully, though, we mostly answered those in class, yeah? You good? Cool. Any questions, Aiden? Negative, yeah, instead of the minus. Then you should be good. Okay. You guys good? Yeah. Uh-huh. On which one? Okay. Mm-hmm. You're technically right unless the question asked for an interval notation. So the idea is right. Just be careful of the directions. Good. Greater than, or equal to. Correct that. Yeah. Correct the or equal to 0. So as long as it didn't say interval notation, technically you're okay. If it said interval notation, then you might have missed some points for reading directions, okay? Cool. Let's come down to number 50. Oh, did you guys get false? Or did they trick you? Did you think of a vertical line not having a y-intercept? If it's anywhere other than the y-axis, or a horizontal line not having an x-intercept if it's anywhere other than the x-axis. But if you had thought only of diagonal lines, it would have made sense to be true. So you had to be really spiffy, you had to think outside the box in order to figure out that it's actually false. The 2 exceptions are the 2 special lines we talked about yesterday. Kyle.
I went back to number 10 that asked you about line to line, and it said 2 special types.
Oh, nice. So it was kind of giving you a hint early on in the homework, huh? Okay. With that, we're going on to section 1.7 after we cover any questions. So any questions on the odds that you had to mark wrong last night, you didn't know why, or evens right now you had to mark wrong and we didn't cover why? You sure? Yeah, Vico. 43B. Let's start there. Let me make it full screen. 43B gives us the directions of, no directions, it's a word problem. I'm surprised there weren't more hands raised on this one. Is it just A and B for 43, guys?
Yeah.
Okay. And mechanics pay is $14 per hour for regular time and time and a half for overtime. The weekly wage function is, okay, so this is W. It just helps in my brain to figure this out. W is going to be the wage in dollars. Who's my other variable? H, right? H is going to be, what do they say? Hours worked per week, right? Hours worked per week. So technically, you could almost, for the directions, you could almost just write this function, say something about mechanics pay, and then W and H. That'd be a great summary for the directions. Letter A says find W of 30, W of 40, W of 45, and W of 50. What are you going to have to think of when you plug in? Which piece? Which piece? Guys, this is a thing, right, for people that are paid hourly, overtime? Yeah. I have a friend that works at Trader Joe's. There are only so many hours she can work per week and has like these weird shifts, and she has to keep track if she stays over or they ask her to stay over. It's her responsibility. Someone says, hey, can you stay an extra hour today? It's her responsibility to know in her mind where or when she's going to hit overtime, because they've also told her, we don't want to give you overtime. So she's like, yeah, I can stay, but then she's like, oh, I've already stayed this many extra hours. This is something they have to be thinking of, because the company doesn't usually want to pay time and a half. Now, when do they pay time and a half? Or when do they have to pay time and a half? Holidays, which is why people that work at Starbucks, et cetera, is like, yeah, I'll work Thanksgiving. No, not that they all, is a choice. Sometimes it's required. Black Friday, et cetera, et cetera, et cetera. But the nice thing is you do get paid time and a half for holidays. Someday you'll be in the workforce. Is anybody already having a job where they actually get some sort of paycheck? It might be a little under the table, but Kyle.
Bonds, they get 3 times their pay on holidays.
Ooh.
And 2 times on Sundays.
Okay, that's nice. That's nice. Coming back. So do you guys see the piecewise functions usefulness? Something is calculating people's pay, right? Time cards? And it's not some little person who's sitting there with a calculator being like, okay, let's figure out what this person I owe for them. No. There's calculator programs, but doesn't the calculator programs need to be told, hey, treat this many hours between 0 and 40, treat it this way, just pay them $14 an hour. But as soon as they go over, now, wait a minute, where does this function come from? What's 560? Any ideas? It's, yeah, 40 times 14 would be 560, and as soon as you go over 40, you get the normal $14 per hour for 40 hours, and then for every hour over 40, you get time and a half. Time and a half is 14 plus 7, 21. Anyway, you could have made this piecewise function. Might have just taken a little bit of work. So letter A, you're plugging in saying, hey, 30, that's less than 40, cool, so it's going to be 14 times $30, right? For W of 30. I'll just put a dollar sign. And you're going to keep on going as soon as you get to the next one, W of 40. Not that yet, because that's going to be 14 times 40. You're allowed to work up to 40 hours a week. But as soon as you get to 45, what's going to happen? Now you're going to have to go ahead and take, hey, 45 is 5 hours over the 40 plus the base pay of 560. Does that kind of make sense what the function is doing, why it's doing it? But what's letter B say? The company increased the regular work week to 45 hours. What is the new wage function? Okay, hold on. I just explained the old one. Okay? And the old one was built on what kind of hour week? A 40-hour a week, right? So what's going to change? Piecewise. So instead of going from 0 to 40, now I'm going to go from 0 to 45, and then I'm going to go above 45. What else is going to change? Is it still $14 an hour? Good. So what's 14 times 45? Ooh, I think, nope. There was overtime before. Anybody have 6:30? Do you guys agree? Anyone? Back up. 6:30. Can't be 560. That was for 40 hours at $14. Now it's 45 hours at $14 an hour. Plus, now we need the extra. Is it still time and a half for the extra hours? Okay, so what stays the same in this? 21. 14 plus 7. And then what's going to change inside here? It's every hour above 45. So the key to doing B was understanding A's function. Kim? 630 comes from, because this is the base pay, this one came from 40 times 14. This one comes from 45. Good. Because this only accounts for the hours over 45 or the hours over 40 being paid $21. If they're working like 50 hours, 5 of those hours get extra money, but the other hours get the normal money. Does that make sense? So the hours get the $14, but the extra hours get the $21. Okay. Are we okay? Any other questions on homework? Kyle?
I had a question on
12? Yeah. Where'd you get stuck?
When we were in the slope, when we had.
Okay.
So I got the y2.
Yeah. For a lot of us, right, the slope formula is really easy as long as it's not written in function notation. As soon as it's written in function notation, it looks weird. So guys, remind me really quickly. F of what variable is normally in this? The x is what's inside, and what do we say the whole thing is? So then look at, this is your x1, this is your y1, this is your x2, this is your y2. If it helps, rewrite it to be f of x is y, and f of x, there you go. Does that make sense?
But it's the slope.
Oh, I thought you didn't know how to plug in. Okay, so then y2 minus y1 all over x2 minus x1. Double check my math, guys, but I'm pretty sure this is 10/4, which would be 5/2. That sounds right from us grading. But you also needed the entire line. Why would this have been a bad idea to try to go straight to?
Because you still need to work with.
You don't have a b. Because how do you see b's? Isn't that when x equals 0? We don't have an intercept. Well, forget that guy, but didn't I tell you guys to forget that guy anyway? What guy should we be thinking of? Not the slope-intercept form, but... Just if you're confused as to what to plug in, remember with point slope, I need a y to stay, I need an x to stay. I'm going to choose 1 point, x1, y1, and 1 m. I already have 5/2. Oh no, what point? I have 2. Doesn't matter. I just need 1. Plug in that one. Simplify. It'll be the same thing as if you plug in that one. So which one looks better to you? Yeah. Simplify, and you'll get, whether you plugged in that one or that one, the exact same equation. I'm not doing the mental math. I think I'm remembering.
Where did the 2 go?
No, it's a minus. I'm just remembering what the answer was. You would distribute your 5/2. You'd have a negative 5/2 plus 2, which is plus 4/2. Negative 5/2 plus 4/2 is negative 1/2. Dun, 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 dun. Anything else? Going once.
I don't know how to draw. For the y, I stop at the x, but for the y, always cross.
For the x, because you understood the x is like plug in, right?
Yeah, but for the y, like, can you see it?
Yeah. Yeah, let me come look. For the rest of you guys, let's go ahead. I'm just going to peek at Kim's work and try to help. Why don't you guys go to notes? We're going to come back to absolute function or absolute value for just a second, even though you guys didn't get stuck on it. But first, let me just have you get the first page of notes down, and you should know exactly where we're going today. If not, look at the backboard.
Or
Didn't Kyle already say today, like, hey, it shifted down 1, right? Like, it's kind of ingrained into your heads. It's just we need to review a little bit. So, what are we reviewing first? Shifts. What are we reviewing first? Shifts. So we take all the parent functions from 1/6. The radical function looks like this. The parabola, the cubic, the absolute value function. Maybe even the steppy one. Not him so much. And we think about how can they change? How can the parent function change? So my way of remembering transformations, just in general, I'm going to say it here at the very, 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 very beginning, and then I'll just use it throughout the rest of class. Vertical transformations always are outside and what you expect. They're outside and they're what you expect. If it's a plus on the outside, you're going up that amount. If it's a minus on the outside, you're going down that amount. You guys can see it here in that there's a parent function with an addition outside, parent function, and subtraction outside. How is horizontal different?
It's inside and opposite.
Horizontal is both inside and, I don't like to use the word opposite, because in one case it's actually the reciprocal, which is different. So I would say unexpected. I mean, hopefully you guys get to where you're expecting the unexpected. Ooh, that's good. But I'll just say it's unexpected, meaning if you see a minus on the inside, you're going. If it's an addition on the inside, you're going left. It's kind of like counterintuitive, at least a little bit counterintuitive. So if you guys have shifting, and I were to give you something like g of x is equal to the square root of x minus 1 minus 7, how can you take the knowledge that you gained from last section, not using a calculator, just using by hand, in order to do the proper transformations of these functions? Well, square root of x function, where is he normally? 0, 0. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. That's the normal one. We could call that one the parent function. But what are we doing to him? Write 1, 7 down, right? 1, 2, 3, 4, 5, 6, 7. So what are we taking right 1, 7 down? Everybody. So the 0, 0 goes right 1, 7 down. Perfect. The 1, 1 goes right 1, 7 down. The 4, 2, square root of 4 is 2, goes right 1, down 7. Right? Do you guys think that might be just a little bit trickier because of some of the functions from yesterday? So keep your parent functions close. And if you see a transform function, think first, where did he come from? Maybe graph just a few points and do the proper transformation to that. That's my advice anyway. So that you have still a somewhat precise graph. Because if you have 3 points to almost any graph, you should have the general idea. The only exception would be a parabola. If you just picked like these 3 points, that's not such a good picture of the whole thing. You would want maybe the vertex, one on either side. That's probably the smarter way for that. But what else do we have besides shifting? So the origin went right 1, this one went right 1 before, and this one went right 1 before. Because of the minus 1. Yeah. So if you want to think about it, we could rewrite this as this, not the square root, f of x minus 1 minus 7. If we're using the parent function of square root of x, x minus 1 is inside and the minus 7 is outside. So that's our vertical shift, horizontal shift. Good? Okay. Mirroring, reflections. Shifting, the shape doesn't change. Reflections or mirroring, the shape doesn't change. But there is some flipping that happens, right? Think about my clue. Vertical, horizontal. Which one would be vertical? It doesn't even have the word up here. The top one or the bottom one? Top one, right? Vertical flip. Wait a minute. It's not a vertical flip. It says x-axis. Think about it. If you're flipping about the x-axis, isn't that a vertical? What's up is down, what's down is up. Isn't that a vertical flip? So then is this one a horizontal flip? The answer is yes. It's just weird because the name is about the y-axis. But technically, my trick still works. What's right was left, and what's left is right if you go across or in the y-axis. So my vertical, horizontal trick, clue, yeah, whatever you want to call it. Way of remembering. Still good. Still valid. I'll give you a couple more seconds to get down what you need. go do something. What if I was to give you something like g of x is equal to negative absolute value of x plus 2. We'll just stop there. Okay. Who's the parent function? I want the parent function to be someone such that I could write this negative. Who's the guy that has the x plus 2 being plugged in and the negative on the outside? Who is that? Absolute value of x. Plug in 0, 0. Plug in 1, 1. Plug in negative 1, 1. What's going on with this guy? Left 2 and flip it how? Outside, vertical flip. So the technical, we would say something to the effect of shift left 2 and reflect, if you want to be super technical, in the x axis, reflect over the x. So can't I take one point at a time and go left 2 and go, well, wait a minute, does this one flip anywhere? Like, can the 0, 0 flip? He stays there. But how about this guy? I'm going to take him left 2, but then where's he going to go? Flip down. And this guy left 2 and flip down. If you want to think about it, you can once again use your points. You have 1, 1, 0, 0, negative 1, 1. If I'm flipping, vertical flipping, what I'm doing is changing the sign. So I'm still going to have in my new one, I'm still going to have 0 and, 0 minus 2, which would be negative 2. And 0 times a negative is still 0. But all of a sudden, negative 1 minus 2, negative 3, needs to flip the y. And this one, minus 2, needs to flip the y. There are ways of actually mathematically doing the transformations that you're supposed to be doing to the x's and to the y, which can make things a little bit easier with hard graphs. Last one.
Annihilation.
Woo! Last one. Distortions or dilations. Stretching and compressing. Shrink and stretch, I think, is how your book did it last year. Is that right? Shrink. I'm going to put a quick little vertical stretch by factor of c and horizontal stretch factor of 1 over c. The horizontal one is unexpected. Vertical, it's by a factor of what you see itself. Horizontal is going to be by a factor of the reciprocal of what you see. The reciprocal of what you see. Now, technically, the stretch shrink thing, that's up to you as to whether it's growing or getting smaller. So in general, a vertical dilation, all vertical dilations will always be by a factor of what you see. All horizontal, whether it's stretching or shrinking, will always be by a factor of the reciprocal of what you see. How do you do by a factor for vertical? Multiply the y's. And for horizontal, multiply the x's. Kiddos, these are all the transformations. We didn't get to do an example of dilations, but there are some examples in the book. So fully attempt homework for Monday, but I realize we're going to have some questions stuck, but still post your photo on Google Classroom by 7 a.m. that you fully attempt as best you can. Dilations we'll probably have to master a little bit more on Monday. Sound good? Cool deal, cool kids. Transformations, go play with them this weekend.